Hi, Trista. I wanted to show you really quick how you do this for question number 9 because it's kind of it can be an awkward question. You can see here I drew a picture of the Earth and I'm showing an alpha particle that's moving eastward along the Earth's equator. Um, what you have to learn, what you have to catch from this is the Earth has a magnetic uh, or a magnetic north pole at the bottom or at the geographic south, and then a magnetic south pole at the geographic north pole. So that means that for the Earth, the magnetic field goes from north to south like this. Okay, and it happens on both sides, obviously. But as this alpha particle is moving eastward along the Earth's equator, it will be pushed by the Earth's magnetic field. And so um, really what you do is you would take your right hand, so your thumb would go in the direction that the alpha particle is moving, and your fingers point from north to south at the equator. So if you can kind of see that, like, there's a north here and a south here, so your fingers would point up at the equator, and that means your palm then pushes away from the surface of the Earth. That's kind of hard to see. If I keep drawing here, maybe just off to the side, there's if you look at the Earth from the side, I guess you could say, the alpha particle, it would travel along the curvature of the Earth like this, because it's basically, if you travel in a straight line relative to the surface of the Earth, you'd be just looking just at a little piece of it, and it would be going horizontal like that. But if you look at this now, in that second sketch I just did, the force of gravity acting on this, the force of gravity will be trying to pull the alpha particle down. But if you use your right hand, your fingers pointing to where the North Pole would, or from north to south, I should say, and your thumb this way, your palm will push away from the Earth. And that's not easy to see, but what it really means then is that Fm is pointing away from the Earth under this configuration, and the force of gravity is pulling down. So if it's going to move in a straight line, then those two forces have to be balanced, because the alpha particle is not being pushed away from the Earth by the magnetic field, and the force of gravity isn't strong enough to pull it into the Earth so that it crashes into the Earth. So that's not easy to see, but the math then becomes basically the force magnetic up has to equal the force of gravity down. So you were doing circular motion. I think I saw your picture there, but and that's on the right track. But in this, whoops, let me back up here. Because what that really means in this case is we just say that mg is, oh, no, sorry, that's not mg. Sorry. What we'd say then is that QVB is equal to m times g. Okay, so you're trying to solve for v, and if you're dealing with the mass of an alpha particle, that goes right here. So you get that from the formula sheet. G is 9.81, and then you solve for v. So anyway, that's not an easy one to see. You have to kind of walk through that, but there could be another question like that later. So hopefully that was helpful.